Hi, my name is Luca, and I'm an engineer on the SwiftUI team. Today, we are going to discuss how you can bring widget to life with some new, exciting capabilities. Widgets are a beloved part of the iOS and macOS experience, and now, with interactivity and animation, they are even more powerful. Interactivity allows your user to directly manipulate the data in your widget, creating powerful interaction to execute the most important action in your app. And animation brings widget to life by helping user get a sense of how the content has changed and what's the result of their action. I'm super excited about all these new capabilities, so let's get started. First, we are going to cover animation and how easy it is to make your widget look great. After that, I'm going to walk you through how to add interactivity to your widget. Let's start with animation. Throughout this talk, we are going to use an app that my friend Niels has been working on to keep track of the caffeine intake during the day. It already has a widget that shows the total amount of caffeine and the last drink I had today. If I recompile my widget with the latest SDK, every time the content of the widget changes, the system is going to animate the transition between the entries with a default animation. We're going to add some tweak here to make it look even better. But before we jump into Xcode, let me briefly talk about how animation works with widget. In a regular SwiftUI app, you use state to drive changes to your view. And animation are driven by state mutation, using modifier like with animation. But widgets work slightly differently. Widgets don't have state. Instead, they create a timeline made of entries, which correspond to different views rendered at a specific time. SwiftUI determines what is the same and what is different between the entries, and animates the parts that have changed. By default, widget gets an implicit spring animation and various implicit content transition. But you can use all the transition, animation, and content transition API that SwiftUI provides out of the box to customize how your widget animates. I won't go into more detail about how all the animation primitive of SwiftUI work. For that, there is a fantastic talk called Explore SwiftUI Animation. Okay, time to open up Xcode and show you how, with few tweaks, your widget can be as fancy as latte art on your morning cappuccino, and how the new Xcode Preview API can help you iterate quickly on this animation. Here I have all the views that comprise my widget. The main view has a V-stack with two views. The first showing the total amount of caffeine, and the second, the last drink I had today, if present. Note how I'm using the container background modifier here to define the background for my widget. These allow it to show up in all the supported locations on the Mac and iPad. Normally, to be able to see your widget animating, you will need to have a bunch of entries and wait for their moment to appear on screen. But that can be tedious and will slow you down. But luckily, we have a great solution with a new preview API we're introducing this year. I can define a new preview for a widget in system small and pass the type defining my widget. And now I can specify how to render a timeline with some entry I've defined earlier. When I do that, in the canvas, I can now see a preview of my timeline and how every entry will look like. But check this out. When I click through the preview, I can see how my widget will animate when transitioning between entries. This is pretty cool. And this is only scratching the surface of what this new preview API is capable of. Make sure to check out the session build programmatic UI with Xcode Preview to learn more about this new, powerful API. Okay, time to start tweaking this animation. The first thing I want to do is start with a text for the caffeine amount. Right now, it is just crossfading with the next value, but I really want to add some drama to the value going up. In this case, the view is not changing, but only the text content is. And to animate that, we can use a content transition. And I'm going to choose to add a numeric text with the value of my caffeine. This is a content transition that is made specifically for important numeric value that we want to give prominence when they change. I think it's looking great. Now I want to focus on the view showing the last drink. I want to add a transition to emphasize that a new drink is coming in. The first thing I want to do is to use the ID modifier to associate the identity of this view with the specific log it is rendering. This will inform SwiftUI that whenever this log changes, this is a new view and we need to transition to the new one. And now I can specify a transition. I think a push will be good. And from which edge? I think from the bottom is a good choice. Okay, you already know what to do now. Back to the preview canvas. And yeah, I like this transition from the bottom. One last tweak. I get a little jittery when I drink that much coffee, and I want that reflected with the animation curve for this transition. What's great is that, like in any regular SwiftUI app, I can use the animation modifier and choose a smooth spring with a shorter duration. And bind that animation to my log value. And now the animation will match my caffeination. I feel pretty good about what we have now, so let's switch our attention to interactivity. With interactivity, you can execute action right from the widget. Before we jump into Xcode, I want to take a moment to discuss the architecture of how widgets work. This will allow you to create a better mental model for how interactivity works. When you create a widget, you define a widget extension, which is discovered by the system and run as an independent process. Widgets define a timeline provider that returns a series of entries, which are effectively the widget model. If a widget is visible, the system launches the widget extension process and asks its timeline provider for entries. These entries are fed back into the view builder that is part of your widget configuration and used to generate a series of views based on these entries. After that, the system generates a representation of this view and archives them on disk. When it's time to display a specific entry, the system decodes and renders the widget archived representation in the system process. Let me pause for a second and reiterate this last point. Your view code only runs during archiving. A separate representation of your view is rendered by the system process. But if your data is not static, you might want to update those entries. You can do that by calling the reload timeline function in your app whenever you're updating data that is displayed by your widget. This will repeat the process I've just described, regenerate new entries, and archive new copies of the view on disk. There are three important takeaways with this architecture. First, when your widget is visible, your code is not running. You drive changes to the widget content by updating its timeline entries. And this is also true of interactive widget. Typically, updates to widget are done on a best effort basis. But importantly, reload initiated from an interaction are always guaranteed to occur. With this out of the way, let's look at how to add interactivity. What's great is that you can use control that you are already familiar with, like button and toggle, to make part of your widget interactive. But remember, since widgets are rendered in a different process, SwiftUI won't execute your closure nor mutate your binding in your process space. So we need a way to represent action that can be executed by the widget extension and invoked by the system. Thankfully, there is already a solution to this problem: AppIntents. You might have used AppIntents to expose actions for your app to Shortcut or Siri. And now, the same intent can be used to represent the action in your widget. At its very core, AppIntent is a protocol that allows you to define, in code, action that can be executed by the system. For example, here I'm defining an AppIntent to toggle a to-do item in a to-do app. An intent defines a number of parameters as inputs, and an async function called perform, where you will have the business logic to run your intent. AppIntent are very powerful, and there is a lot more to know about them. So be sure to check out the Dive into AppIntents and Explore Enhancement to AppIntent session from WWDC 2022 and 2023. And to support the ability to execute AppIntent right from the UI, when you import both SwiftUI and AppIntents, there is a new family of initializer on button and toggle that accept an AppIntent as an argument and will execute that intent when these controls are interacted with. Note that only button and toggle using AppIntent are supported in interactive widget. Other control won't work. And of course, those initializers work in our app as well, which is cool because you can share the AppIntent logic between your widget and your app. Let's go back to Xcode and our coffee tracker app and add some interactivity. Currently, the user can log a new drink only by opening the app. But where interactive widget shines is as an accelerator to surface the most important action in your app. And for my app, this is definitely the logging of a new drink. So let's add that to a file I've already created. The first thing I want to do is define a type that conforms to AppIntent to log a new drink. We'll give it a human-readable title that can be used by the system. And then implement the perform requirement by logging an espresso to our store and returning an empty intent result. Something that I want to call your attention to is that perform is an async function, and you should take full advantage of it if you're doing any asynchronous work, such as writing to a database. Exactly like I'm doing here when I'm awaiting the log writing operation. As soon as your perform returns, the system will immediately initiate a reload of your widget timeline, giving you the opportunity to update the content of your widget. So again, make sure to have persisted all the information necessary to reload your updated widget before returning from perform. I've hard-coded the drink to be an espresso, but of course we want to be able to pass the specific drink to log. To do that, we can add a store property with the addParameter property wrapper and an initializer that populates all the parameters. It is important that I use this property wrapper because only the store properties that are annotated with it are going to be persisted and will be available when the intent is performed in your widget extension. Before we add the button to invoke this intent, I want to highlight an important ecosystem benefit of using AppIntents here. This AppIntent I've just defined is going to be available in Shortcut and Siri, so the investment in defining it here will pay dividend to your user experience beyond widget. And now we are ready to add the button to the widget. Let's create a new view holding our buttons. In this view, I'm using this button initializer that takes an app intent, so we can pass the one I've just defined. And let's add this view to the rest of the widget with some spacer. Now we have everything in place. Let's see how this is working out on the widget by building and running. A little tip here. You can actually have directly build the target for the widget extension, and Xcode will install the widget right on the home screen for you. My widget now has the button I've just defined. If I tap on it, I can log this last cup of espresso. But there is also one additional change I want to make so that my widget provides the best user experience possible. When your app intent finishes to perform, it will cause a widget to reload its timeline. This can introduce a small latency from the action to the resulting change in the UI. But this latency can become more pronounced with iPhone widget on Mac. And so we are providing a solution out of the box for it. For example, in my widget, the value showing the total amount of caffeine won't update until an updated entry arrives. We can annotate this view with the invalidatable content modifier. I've added this widget from my iPhone to my Mac. So let's tap on that button. The view showing the caffeine amount shows a system effect to indicate that its value is invalidated until an update comes in. We just saw button in action, and how with the invalidatable content modifier, you can help user improve the perception of latency. Use this modifier judiciously. You don't need to annotate every single view that might change. You should use this modifier with views that are meaningful to set the right expectation with your users. Toggle goes one step further and will optimistically update its presentation when interacted with, without having to wait for a round trip to the widget extension and back. This is done automatically on your behalf at archive time by pre-rendering the toggle style in both configurations. Make sure, if you define your own toggle style, to check the configuration is on property from the style and use that to switch the appearance. This concludes our overview for interactivity and animation. With animation and interactivity, you have the opportunity to infuse new life into your widget. And with widget, now in all these new locations, you can bring this little, delightful interaction to your user wherever they are. So make sure to fine-tune the animation for your widget with the help of the new Xcode Preview APIs. And look out for the most important action in your app and surface them in your widget, giving your user powerful interaction whenever and wherever they need them. Thank you!